going to do a talk just to give you a rough idea what we've been working on for the last 1 year, maybe 18 months. If you're following GStreamer development on a daily basis, then there's probably not much news for you in here, but most people aren't, so we just like to repeat what we've been working on. Just a quick introduction, who are we? I'm Tim Müller, I'm one of GStreamer co-developers and release managers, and Sebastian.
Well, basically the same. I did the last few GStreamer releases and probably also touched every piece of code until now. So.
Right, and we work for Centricular and do GStreamer consulting. Right, so just a quick introduction in case you don't know. What is GStreamer? It's basically a bunch of libraries to do multimedia processing. It's pipeline based. It's a bit like Lego. You can just take different types of elements and you can hook them together, and then your media flows through it. It's got lots of different components, pads, elements, as we call them. We provide plugins, which you can wrap other libraries around it. You can provide all kinds of different functionalities, and these plugins are basically your kind of Lego pieces that you can combine together. And we provide a unified API around all that that you can use to do all that. Right, and we wrap everything. We don't invent everything from scratch, but there are lots of good development stuff, work that's being done, codecs that are being written, libav, ffmpeg, etc., etc. All these libraries, we don't reinvent them, we just use them and make them available via our abstract API. We've got very high-level API if you just want a play bin or a camera, Photoshop, sort of for a photo booth type of application. We have a high-level API for that. If you have very low-level stuff, you want to do very dynamic pipelines, you can do that as well. There's some high-level API missing. We're going to get there one day, but we integrate with other frameworks, both in terms of being used by other frameworks and using other frameworks. So we can be used in WebKit, Firefox, Clutter, all that we integrate with it. You can use us on Windows. So our goal is basically to be adaptable and work everywhere. All right, what are we going to talk about? Just what happened in the last year or so with GStreamer. In case you haven't heard, we've released GStreamer 1.0 a while back, and GStreamer 1.2 is the next stable release version that's come out last October. There's lots of new features. The binary platform support for Windows, etc., and OS X and iOS and Android. And after that, in the future, we have GStreamer 1.4, GStreamer 1.6, which are our new stable feature releases. So we kind of adopted a glib versioning scheme, which I'll mention on the next slide. Right. So just in case you have noticed, I'm just mentioning it because people are confused by it apparently. So 0.10 is the old and ancient version, not developed anymore, not maintained. Don't use it for new stuff. We realize some people have to continue with it, but it's dead. Forget about it. 1.0 is the new stable API. If we ever break API again, hopefully not for a long time, it will be 2.0. So everything that starts with 1 point something is backwards compatible. It's very much like GNOME or glib, basically. We've started separating feature releases from bug fix releases. So we have the glib versioning scheme now, and we do 1.0 and then 1.01, 1.02 for bug fix releases, and then the big feature versions are called 1.2, 1.4, 1.6, etc. All right. So we've got quite a few bug fix releases we've done. The current stable release is 1.2, 1.4. Hopefully it's going to come out around March, April. It took us a very, very long time to get from 1.0 to 1.2, about a year, and I think that's much longer than we wanted to take. Originally we had planned to do a new feature release every 3 months or so. That didn't really work out. So hopefully we can, I think our goal currently is to stabilize on a 6-monthly release cycle, so we can roughly do releases around March, April, and September, October or so. Well, in general, I think all the major applications I'm aware of have been ported to 1.0. There is a GStreamer support in Firefox now, which is being worked on, and Enlightenment has been ported to 1.0 as well. Just a quick review. What does 1.0 actually mean? What have we changed? In general, it's just an API cleanup. Stuff we wanted to get rid of, stuff we wanted to fix. In general, from an application point of view, the changes are more of an evolution than a revolution. If you have an application, most stuff is going to be the same. You will have some minor changes you have to make, but most of the changes affect plugins and low-level stuff. Conceptually, it's pretty much the same. So from a risk perspective, bugs are always there, but from risk perspective, it's well understood how it works, how the threading works, how the interaction works, and we haven't changed that basically. But we did fix some of the big problems that we had in 0.10, memory handling, etc. And hopefully, well, the 1.0 API will be stable for quite some time. Bindings are now provided via g-object inspection. We couldn't do that in the past because of our custom mini-object stuff, which were, well, special. So GI couldn't handle that. But now we've changed that and it can be handled, and it's all good. All right. Binary releases. We now have binary releases for Windows, OS X, Android, and iOS. So you can hack on all these platforms with GStreamer and write stuff using open source multimedia frameworks. And it includes all plugins, well, not all almost all plugins. If any plugins are missing, give us a shout and maybe we can just add them. It's usually an oversight and not intentional. Unless they haven't been ported, then it's intentional. But it's usually not so hard to port them. All right. Oh yeah, sorry. Development 1.4, hopefully it comes out in March, April. We've been working on it since September. As I said, it's going to be released very soon. Lots of new features. And Sebastian's going to tell you a bit more about all that.
So one of the very big changes we did for 1.0 and the following releases is for hardware integration. If you want to use all kinds of special hardware, especially on embedded devices, stuff like hardware codecs, it was possible to do that in 0.10, but it was quite awful and hackish. You really didn't want to do that. So what we now have is interfaces to share all kinds of hardware contexts between devices. So for example, you can share a display handle between all the elements automatically. We now have stuff to handle all kinds of different memory representations. So for example, in 0.10, it was only possible to have something like system memory, something that you can allocate with malloc. Everything else was just a hack. And what we now can do is we can wrap stuff like DMA buff or EGL images or stuff like a VA surface of VA API. Then what was added quite recently is we have proper negotiation between the elements to make it possible that the hardware features are, well, the best possible solution of the best possible combination of elements is selected that are available on your computer. So for example, well, on most of the latest Intel laptops with an Intel chipset, you will automatically use the VA API elements for decoding if it's possible, even without the application having to know about that. And then, well, over the last months, we also made lots of further improvements there. There were lots of bugs still, and I think nowadays it can just work out of the box. So what does this mean? Basically, you're using stuff like, well, WebKit or just your video player on your desktop. It will just use the hardware codecs that are available without the applications knowing about that, if they are written properly. Also on embedded systems, like, well, on Android or on the Raspberry Pi, stuff just works. And because of all these new interfaces we added, there are much less workarounds, and you actually have clean code, and you don't have to cry if you read the code later. Really, it was awful before. So especially on the Raspberry Pi, what we now have is a proper integration of OpenMax IL. What is now possible, for example, is that you have on this $25 mini computer, you can have HD video decoding, going zero copy to the display. It's just happening extremely fast without using any CPU. And people are using this nowadays for, well, just video playback, but also complex stuff like having a multi-screen display wall or producing some kind of streaming server. So for example, the Raspberry Pi also has some kind of camera you can use, and well, it can automatically use the hardware encoders on the device to produce HD video as H.264, and then you can send it over the network, and all this works in GStreamer now without well, anything special to know for the application. Then other stuff has happened. GSTV API was improved a lot by the Intel guys. Again, as I mentioned before, it's just working now. That wasn't the case before. It was the promise for the last few years that it's just working, and now we're finally there. Then recently, what was started is a decoder element that is using the Video for Linux 2 decoder API. So many of the hardware codec manufacturers, people like companies like, well, Samsung or ST are now providing Video for Linux drivers for the hardware codecs, and well, we now have a proper plugin for that. And again, it's just working. For other companies, well, the hardware industry is a bit slow sometimes, but stuff is coming out. Stuff is going to well, we see that they are working on stuff, and I think in the near future we will have proper hardware integration for all the different chipsets out there in GStreamer. Then some other things that have happened is, well, there are the OpenGL plugins we have. OpenGL is a bit special. You can't really use all kinds of different threads in OpenGL. You usually have to do everything from a single thread. Well, in GStreamer we have the problem, we are completely multi-threaded. Everything is happening in a different thread, and this was quite difficult to implement. But nowadays it's possible to have all kinds of GL-based elements in your pipeline that can interact without problems with software-based elements, that can interact without problems with other hardware-related elements. So you can just, for example, have your a filter somewhere in your pipeline that does some kinds of effects or deinterlacing or whatever with GL shaders. And well, it currently runs on all kinds of platforms. It works on OS X, it works on Android, it works on Linux, of course. It works now on the Raspberry Pi. Then we integrated lots of smaller things. So for example, the blues elements were integrated. So we now have well, support for directly using, say, a Bluetooth headset from GStreamer. Then lots of work has been done on the HTTP adaptive streaming protocols, stuff like HLS, Dash, Microsoft Smooth Streaming. So that's basically what everybody nowadays is using for stuff like video on demand. And also some work there has been done on, well, unfortunately, DRM stuff, because content providers want that. And even that stuff is now working in GStreamer. Then lots of work has been done on MPEG-TS support, on DVB support. So for example, well, if you have some kind of a DVB device and want to plug it into your laptop, it's probably going to work now, if it's supported by the Linux DVB API. Then we integrated H.265 or HEVC support. We have now parsers for that. It's integrated in all kinds of elements. For decoding, we are currently using the really great decoder that is inside libav. Then we have support, well, for the next generation codec from Google, the VP9 codec. which is also, I think they recently started to use it on YouTube. Then we also have initial DALA support, which is well, the next generation codec that is currently being developed by XIF and Mozilla. It's not stable yet, well, but you can experiment a bit with it. It won't be doing much useful stuff, but if you want to help on development there with GStreamer, you have very easy ways to test all kinds of video inputs there, test how the decoder is working. And I think it's a good toolbox if you want to work on the codec, because you can have all kinds of inputs directly handled by GStreamer and then put it into the new encoder. Then many changes were done on the RTP, RTSP stuff, both client side and server side. So what we now have is in the server, for example, authentication. We have support for encryption via SRTP. We have support for stuff like retransmissions. So for example, RTP usually is using UDP. Packets can get lost, especially on wireless networks. And there's now support for, well, requesting packets that were lost. This can happen completely automatically. Then we improved the net clock support in GStreamer. So what does that mean? We have a generic object in GStreamer that allows you to share a clock of a single device over the network with all other devices. So what you can have, for example, is all kinds of displays showing exactly the same video and audio completely synchronized between devices. This worked quite good before already, except for, well, on wireless networks where sometimes it can happen that you have lots, very long delays because, well, for example, you are currently walking with your mobile device from your living room to your kitchen, and then maybe you lose the Wi-Fi connection for some time, and then it can happen that sometimes a packet is going to take multiple seconds until it arrives on your computer, and this made the estimation of well, the usage or the synchronization to the master clock inside the network quite unreliable. But some improvements were done there to, well, ignore these complete outliers that are taking much longer than the average packets, and I think it's working very reliable now. Then we also have, of course, Wayland support, the great new thing that people are already starting to use now. Especially in the GL plugins, the Wayland support is really great nowadays. It's even supporting the new subsurface stuff, so you can well, integrate your video via the video sync into Wayland applications. Then the GNonLin and GC editing services libraries were also ported to 1.0. Lots of improvements were made, and finally we will now have a new PTV release. PTV is a video editor based on GStreamer, and, well, they didn't have a release since, I don't know, 3 years, 4 years or something. And I think now when they are making the new stable release, you will have a good free video editor based on GStreamer that can actually be used and that does not crash all the time like before. Really, in the past it wasn't, in my opinion, it wasn't really usable, but now it is. And then, of course, we fixed lots of bugs. We have Bugzilla under control again. In the past, in the GNOME Bugzilla, we were in the top 10 products with the most bugs. Now we are out of there. I don't know at which position we are now because, well, it's not listed there. And I think in the last year or last 1.5 years, we fixed about 1,600 bugs in Bugzilla. So lots of stuff has happened there. Of course, some of them were also feature requests.
Right, sorry for the audio noise. Quick look into the future. I think we've got about 10 minutes left. 1.4 coming up in March, April. After that, 1.6, hopefully around September. Of course, lots of new features. One thing we really have on our roadmap is documentation and tutorials. I think we need sort of more focused, better documentation. GStreamer.com, which has nothing to do with the GStreamer project, has quite good tutorials, so people kind of land on that and then they're confused. So because they're for 0.10 as well. But so we really need to work on that. So that's something we have planned. In general, there's lots of stuff around webby stuff, HTML5, etc. WebKit, etc. There's lots of media source, audio source integration. They need kind of special API to signal stuff, which we don't have in GStreamer yet. So there's kind of lots of stuff in Bugzilla that's pending, where we need to expose additional information to make all that work and usable in WebKit. You know, picture-in-picture, different audio types and subtitle type streams, and new buffering modes in Playbin. Well, VTT, that's well, subtitle stuff as well. WebRTC, of course, you probably have heard of. There's work being done there. 3D video is one of the biggest things we haven't really done yet. Well, it's been done in 0.10 as a sum of code project, but it was sort of very separate from the normal stuff. You couldn't integrate it because of the caps explosion stuff we had. So, but anyway, in 1.0 we can do that. We have some very, very minimal API for that, but there's more API that needs fleshing out. So, you know, we kind of need to put our heads together and look at all the requirements and figure out a way to signal all that properly. It's a bit messy, so you just need to, someone needs to do it, but it's on the roadmap. I've been saying that for years, haven't I? More hardware support, but this time for real. More hardware support, well, there's always more to do, but I mean, we're kind of making improvements, especially via the open Mac stuff and then the vendor provided. Well, since vendors kind of are narrowing down on the Video for Linux API for providing decoder support, I hope that will get us there soon. Blu-ray, also something I've been mentioning. I mean, the truth is the video LAN people have actually been doing all the hard work, so there's a library and everything, we just have to hook it in. Shouldn't take much time. I'll do it one of these days. All right, that brings us to the end already. Do you have any questions, comments, anything at all? Yes.
You mentioned device discovery. How do you plan to get that working when you have a composite device with lots of hardware device nodes? But that makes a single logical device, like Everrad has several components.
Sorry, can you repeat that? I didn't.
So you mentioned hardware device discovery.
Hardware?
Device discovery.
Oh, discovery. Yes. Sorry.
How do you plan to make that work when your device is actually a logical device made of multiple hardware components that should be regarded as a single device in this case?
We don't have a plan for that. We have to figure that out. The idea for the device discovery and well, I haven't actually mentioned the device discovery, have I? But yeah. Sorry, I skipped over that. Well, it's kind of blocking on me currently. But the idea behind that is it's supposed to be a very simple API targeted at what we know applications now want. Basically, you have an application that says, you know, give me the camera devices or capture devices, or give me a list of DVD drives or a sound output or something. I mean, it's supposed to be very, very high level, very basic. It's not supposed to be, you know, you can discover everything that's there. We're not gonna, it's gonna be simple. And we're probably, I mean, it's well possible that we're gonna say, we're just not gonna deal with that at all. So, but I mean, I don't have an answer yet, really. So, any other questions? Sorry.
So much easier to find a transcoding application based on FFmpeg rather than GStreamer?
I don't know. Have you been looking for a transcoding application in GStreamer? There's Transmageddon, for example. Have you tried that? All right. Well, it's. I think it's very simple. It's supposed to work quite well. So I don't know if it has a million options to do stuff. There's a SourceForge project called GenTrans, which is more like a command line thing with different specialized support for transcoding. But yes, I don't know. There's still sort of well, there's still things we could do better. I think applications exist. We don't have dedicated transcoding API yet. Something like a transcode bin, something on the list, but no one's been working on that yet. So there was another question here somewhere. Well, yes, we have unit tests, of course, in all the source modules. So you can run your make check in the source tree, and it kind of tests all kind of stuff. You can run a make check dash valgrind, and it runs all the unit tests through valgrind. That's what we have. There are sort of test suites which you can run over media files. There's work going on to integrate all that into Jenkins, buildbots, etc. So it's it's not perfect yet. There's quite. I mean, I can imagine lots of stuff. I mean, fuzzing. I mean, we don't actively do it, but the truth is, I mean, there are other people who do it, and then they start finding bugs. And but also, well, I mean, there are commercial vendors which use our stuff in their products, and they usually kind of do that internally and then just submit patches. I mean, in the Nokia days, there was lots of stuff where they just had gigabytes full of fuzzed files, and then someone just spent months working through that and fixing all that up. So hopefully we haven't regressed. But I mean, it's not something we actively do, but I think in general it works well. I mean, you can run GStDiscover on a directory full of fuzzed files and make sure it doesn't crash, but just errors out or works. So. Of course, also there are lots of companies who use GStreamer internally for their systems, and they have actually quite good test suites, which are not public, but you can tell because basically you do a change and then they come back later and they say, well, your change has caused the following problem. If you run this, 5 days non-stop, then suddenly you will get that and that overflow, and you say, yeah, okay, good, great, thanks. So. Or sometimes they find these, I don't know, they have stuff that just runs the same test over and over and over and over again, like nothing else. And they say, well, this fails about 1 every 2 million times. There's a race condition somewhere. So, I mean, they exist, but they're not. And there's some effort also going on to push some of that stuff public. There's some new API that people have developed. So I hope, there's work being done in that area. Sorry, we are at the end of it all. So thank you very much for coming. See you around.